Hello, everyone! Today, we begin a fascinating chapter called Working with Fractions. Imagine a cyclist traveling 3 kilometers in 1 hour. How far will the cyclist travel in just 1/5 of an hour? What about 2/5 of an hour? Questions like these may seem simple, but they reveal a powerful mathematical idea. A fraction can act as an operator, helping us find a part of a quantity. Fractions are far more than pieces of a whole. They help us measure, compare, scale, and solve real-world problems involving distance, time, area, and sharing. Through situations like the cyclist's journey, we begin to explore multiplication between whole numbers and fractions. But what happens when both numbers are fractions? Suppose we want to find 3/4 of 2/5, a fraction of another fraction. Visual models allow us to divide a whole into equal parts and examine the overlapping region. This overlap represents the product and reveals a beautiful pattern. To multiply fractions, we multiply the numerators together and multiply the denominators together. This idea becomes even more meaningful when connected to geometry. Consider a rectangle whose length and breadth are fractions. The area of that rectangle is found by multiplying its side lengths. The area of a rectangle with fractional side lengths is equal to the product of its sides, allowing us to see fraction multiplication as a geometric idea, rather than merely a numerical rule. As calculations become more sophisticated, we learn to convert mixed fractions into improper fractions and use cancellation to simplify common factors before multiplying. These techniques make calculations more efficient and help us express answers in their lowest form. Along the way, we encounter a surprising discovery. Multiplication does not always make numbers larger. When both numbers are greater than 1, the product becomes larger than both. When both numbers lie between 0 and 1, the product becomes smaller than both. And when one number is greater than 1 while the other lies between 0 and 1, the product falls between them. These patterns deepen our understanding of multiplication and challenge our intuition. We also discover that the order of multiplication does not matter. Whether we change the arrangement of factors or view a rectangle from a different orientation, the product remains unchanged. Multiplication of fractions is commutative. The chapter then turns to division of fractions. Instead of treating division as an entirely new process, we reinterpret it as a multiplication problem. What number must be multiplied by the divisor to produce the dividend? This naturally leads to the idea of reciprocals. By multiplying by the reciprocal of the divisor, division of fractions becomes both elegant and efficient. By the end of this chapter, fractions are no longer just numbers written with numerators and denominators. They become powerful tools for reasoning, measuring, comparing, scaling, finding areas, and solving a wide variety of mathematical problems, laying a strong foundation for algebra and the deeper mathematics that follows.